If you're listening to this, you are probably standing in front of my poster titled "A New Resonance Mechanism in the Swift Hohenberg Equation with Time Periodic Forcing," and I'm not around to tell you about it. This recording will hopefully give you an overview of the work and the main results. If you have more questions, you can look at our papers or email me. Similar patterns appear in nature all around us. Stripes, for example, appear on the surface of sand, in clouds, and on zebras, just to name a few places. A goal of the field of pattern formation is to understand how a system picks a particular pattern, say stripes versus spots, and why it is that similar patterns can emerge from systems made up of such widely different constituent pieces. This particular study was motivated by understanding how seasonality affects the growth of desert vegetation patterns. The driving force in these systems is water, and we are interested in what effect periodically alternating between rainy seasons and dry seasons has on a localized patch of vegetation. The model we consider has also been used to qualitatively describe convection in fluids, nonlinear optics systems, neural networks, and even the formation of crime hotspots. We find that a localized pattern that is stable under a constant forcing can start to breathe when a periodic forcing is applied. In other words, it grows in spatial extent for some part of the forcing cycle and shrinks during another part. Depending on the parameters of the forcing, we find that these breathing patterns can, on average, grow to invade the background, remain fixed in size, or decay away. These different behaviors form an interesting structure in the parameter space due to a resonance between the forcing period and the time it takes for the pattern to grow or decay. The periodic forcing actually narrows the region in parameter space where patterns of fixed size exist overall. But because the growth and decay of the localized patterns move in step with the periodic forcing, sweet spots in parameter space are created where it's relatively easier for the pattern to remain fixed in size. In terms of desert vegetation, this means that the periodic forcing will make it harder for a localized patch to remain localized overall, but it may be advantageous for plants to have certain growth times over others.